In this video, we will learn this stack thing. What is the stack? First, we see this word. We will understand this word. And to understand this thing, stack, here I draw a figure. And you see a figure. This is a simple figure. Here you see a simple figure. You can say it a glass, or you may say it a jar, whatever you call it. The main thing is to understand the stack. And suppose you have large number of disks. I draw disks here. Note the size as well, because the size is also important thing when we discuss here. Taking this example shown in the shown on the screen, you see the disks in red, and one can take a large number of such disks. You may take. I have taken three, and now I number these three disks. You see, I have numbered. Now I have to insert these three red disks into this glass jar, blue colored glass jar. Now I insert one by one. So see what you have. I insert these disks in a sequence. First I will insert the red disk with number 1, thereafter 2, and thereafter 3. You see, I have entered the first disk. Now I will enter the remaining two disks in a sequence. And now you may think, what will be the positions of these three disks? Okay, let us see. So you see, now you see all the three discs inside the jar. And I have earlier said that you have to notice the size as well. Size of the disc, you may say the diameter of the disc is only slightly less than the diameter of the glass jar. A significantly small that it just goes inside the jar. Here you see large gap. Here you see large gap, but these are not such a gap. There is no such a large gap. A very small gap. I draw the same figure so that it may look better. Now you see the size, and the second drawing is better than the first because in the second you see the gap is almost negligible. The gap is so small that it just fitted in the glass jar. And here it is to be noted that disc, the first red disc, has gone at the bottom. Now, when you want to take out one disc from this jar, then you see that if you want to take a disc out of this jar, then you will have disc number 3 for the first time. And this means that the disc which goes inside the jar at the end comes out first. And in the same way, the second last disc that goes inside will come out if you take one by one. Then that second last the second disc will come out after the disc number 3. So whenever you see such an arrangement, then that arrangement, that process, or you may say precisely process, when you perform such a process, then this is called stack. And now the question comes in our mind, the C program related to this stack thing. And you should keep in your mind that in a stack as well, the data are stored. Here you see the disks, 3 disks. Here may be in a large number of disks. And in the same way, you can store the data. And if you are storing the data in such a manner, that is the first thing, the data you entered first will come out at the end, and the data you inserted at the end is coming out in the first step, then such a such an arrangement is also called a stack, and hence the data may be stored in such a manner. So since the data can be stored in such a manner, then obviously there will be a there can be written a C program. And this stack thing, the program related to this stack thing can be typed, can be written using the linked list. You can use singly linked list or doubly linked list. I here mention, I here discuss the stack thing using singly linked list. And you know, linked list are made using similar type of nodes. And I have already discussed this linked list. You know, I again here discuss the same thing but in short. You know, in a singly linked list we create a node, and in that list there are, you see, this is a node. In the same way, you see the second node here. So on the screen there are two nodes, and how can we attach these two nodes? This has already been explained. And in the data part, we store data. Suppose this is first data you take for the first time, so that data will be data 1, and here you can type 2 because this is the node number 2. And when you attaching means you place the data part onto this link, and when you do so, you have the you have this structure. I show you, you will get such a structure. Here data ones come, here data 1 comes when you place this data 2 over this next part, then here will be data 2, here will be data 2, and here will be the link part. So when you create a linked list, then always at the end there is a link part. So you see, you do the same thing here. I have taken two nodes. When you take more than two nodes, that is 3, 4, etc., then the linked list will be larger linked list, and that will be like that. I show you like this. Suppose I am taking 4 data, and I am attaching these 4 data one by one, then the resulting linked list will be like this: 1 here, 2 here, 3 here, 4, and here will be. I have shown you earlier attaching of two data, and there you saw that there were three compartments in that list: data 1, data 2, and the next part. And in the same way, if you attach four data one by one, then you will have the structure you see on the screen, that you see on the screen. And you see on the screen data 1, data 2, data 3, data 4, and next. And in a stack, here we are here to learn the stack thing. So if you insert a new node, then if you insert a new node, then obviously you learnt that data will go to the top. This means if you insert data number 5, then that data number 5 will come here. That data that you insert at the end will come here at this place. This is same as we do in the queue. Also in the queue you have seen that the new person coming stands at the rear end, and here as well in the stack thing, if you insert a data, that data will go at the end. And since this is a linked list, so at the end there will be a link. And that link, in our most of the programs, I have taken star next. So accordingly I take here star next. So now I have inserted a data, but the difference between the queue and this stack thing is that when you delete, then if this were a queue, then you know that in a queue front data is deleted first. But here we are here to learn the stack thing. And in a stack, the last data is not deleted first. First, you know, as I have shown you taking the example of a jar, that in a stack, the last data, the last entered data is deleted first. So here in stack, if you want to delete, then you have to delete this one. This node will be deleted first. And how can we delete this last data? I have already said that insertion thing is the same in both, whether it be a queue or a stack. We always insert at the end. The difference between the stack and queue is that in a queue we delete from the front, but in a stack we delete from the rear end, and this will be deleted. The node you see in the red enclosure. And how it can be deleted? The question is, how can it be deleted? And you know for the deletion, suppose this node, suppose the name of this node is you may take anything. I take I take suppose P. The the pointer to this node is P. It is P. So to delete the last node, you know, this is the last node, and here the data part in the last node is data 5 and the link is next. But the question is, where is the link part of data 4? If you have seen the attachment that I discussed earlier, then you can say, then you can answer my question. Where is the link part of data 4? And you, if you don't understand that, then see this video from the starting point, then you can understand that. The link part of data 4 is below the data 5. And to delete the last node, suppose the name of the node containing data 4 is P. For that, here you have to type a C statement, and that statement will be P next of P. You know, the next of P is below data 5. And to remove the attachment, you have to type this C statement P. The next inside P equals to null. Equals to null. If you do, if you type this data, this C statement, then the resulting structure, then the resulting structure will be like this. I show you like this. Like this. This for the data 1, this for the data 2, this for the data 3, and this for the data 4. Here I type accordingly. Here data 1, here data to here data 3, here will be data 4, data 4, and here will be the next part. That was this next part will come in front of us when you delete the last node, and you should understand that this next part, this part, the link here in the last you see after data 4, that link part was earlier below the data 5, and when you type this C statement, then that link part comes in front of us, and the last node, that is that you see inside the, now you see that thing, the last here in the green enclosure will be deleted, will be will get detached, and we have now the new linked list that you see in red, and in this there is one less data. The number of data is less than the earlier. In such a way we do the deletion, and you should keep in your mind that in the original linked list, to delete the last one, in the original linked list we set the second last, remember, not the last, second last link equals to null. So this deletion part is clear now to you, and as far as the insertion is concerned, I have already explained that thing in the algorithm of the queue. You know, in the queue also we do insert a new data at the end, and here as well in the stack thing we insert the new data at the end, but the deletion part was different. In a queue we deleted from the front, but here in the stack we delete from the rear end, from the, and you may say, uh, if you imagine the jar, the glass jar that I have shown in the beginning, then the deletion is done from the top, that is the top data is deleted first, and here if you take this structure, this blue structure in a vertical direction, then data 1 will be at the bottom and data 5 will be at the top. So when you go to delete, then you have to delete data 5 first. And how can we delete? I have just explained that thing, and resulting structure, you see the resulting structure as well, and that resulting structure is in red. If you if you take this red structure vertical, then the data 1 will be at the bottom and data 4 now will be at the top. So I think the algorithm regarding a stack thing is complete, and we will type a program in the next video related to this stack thing, and in that, you know, two operations are important The first one is insertion and the other is deletion. These two are important. Besides these two operations, we can perform more operations such as counting of data inside the stack, searching an element inside the stack, etc. can be attached. But remember, two are most important, and that two things are deletion and insertion. Okay, so far these things and remaining will be discussed in the next video.